Okay, so sometimes you're going to get an example, and in the book it's stated like this right here. It says, determine whether the following numbers are prime or composite, and state how you know. Okay, so again, prime means it's not divisible by anything else, okay, except for 1 in itself. So if it's prime, the only two numbers that should go into this are 1 and itself. Okay, well then I put on your instructions, tell whether the numbers are divisible by 2, 3, 4, 5, 6, 9, and 10. So use those tests that we just talked about. Okay? And if one of those tests, if one of those tests is true, if it's divisible by one of these numbers, then it's not prime. That means it has to be composite. Okay? So let's go ahead and look at the divisibility test for 2. Okay? The divisibility test for 2 says that if it's even, it's divisible by 2. So if I look at 1,200 or 1,237,526 to tell if it's even or not, I'm looking at the last number. Okay? Well, it ends in 6. That means it's even. So the number is divisible by 2. Okay? So right there, it's divisible by 2. So we know it can't be prime because it's divisible by 1 and itself, 1,237,526, but it's also divisible by 2. Okay? So, just for the sake of the divisibility test and using them, or actually, you know what, we're not going to keep going on this one. This is all we need to do. And so we're going to say that it is a composite number, and it's composite because it has more factors, than 1 and itself. Okay? All that means is that more than 1 and the number itself go into it. And we know that because 2 goes into it. Alright? Now let's look at B. Okay, we'll take a look at B here. I'll slide this over. It says, now we're looking at the number 520,611. Okay, so again, we're using our divisibility test. So we're using the divisibility test for 2. Well, the number is 520,611. It ends in a 1, so it's not even. So it's no. Okay, use the test for 3. So we take 5 plus 2 plus 0 plus 6 plus 1 plus 1. Okay, well 5 plus 2 is 7. 7 plus 0 is 0. 7 plus, or sorry, let's try that again. 5 plus 2 is 7. 7 plus 0 is 7. 7 plus 6 is 13. 13 plus 1 is 14. And 14 plus 1 is 15. Okay, is 15 divisible by 3? Well, 15 divided by 3 is 5. So yes, it is divisible by 3. Okay, so that means if I took 520,611, I should be able to divide that by 3. 3 would go into it evenly. Again, because all of these digits add up to 15. Okay, again, 5 plus 2 is 7. 7 plus 0 is 7. 7 plus 6 is 13. Plus 1 is 14. Plus 1 is 15. So again, I know that this number is composite because it has more factors than 1 in itself. Okay? Now, let's say that we came up with the number that that neither of these worked. Okay, so then we would do the divisibility test for 4, and if that didn't work, we'd do the divisibility test for 5, and we would keep going until we found one that did. And if none of them worked, okay, if none of the tests for these numbers worked, then the number would be prime instead of composite. Alright, and let's move on to our last example, our last two examples. Alright, and example 2, it says to write the prime factorization of 36 and then 45. Okay, and I'm going to show you two different methods for these. The first method I'm going to show you is factor trees. And the second method is going to be called, I'm going to slide this over here a little bit. It's going to be called downward division. Okay, downward division. And your book's going to call it division by primes. Okay, ran out of room. Let's slide this over a little bit. Okay, so downward division and division by primes means the same thing. Okay, I call it one, your book calls it the other, but they're the exact same thing. Alright, so now let's talk about these. I'm going to do the prime factorization of 36 using a factor tree, just to show you the method. And then I'll do 45 by the downward division so you can get a taste of both of them. Alright? Okay, so factor tree. Here's how this works. To do a factor tree, you want to break apart 36. Okay, we want to get it down to just prime numbers, to prime factors. Well, so we're going to talk about different ways to multiply to get 36. That's what I want to figure out and put here. Are two numbers that multiply together to get 36. Well, I could do 2 times 18, I could do 3 times 12, I could do 4 times 9. You can pick whichever one you want. I'm going to pick 6 times 6 actually. But it doesn't matter what you pick as long as these two numbers right here multiply together to get 36. Now 6 is composite. I can still break it down. And it breaks down into 2 times 3. Okay? Now 2 is prime, so I'm going to circle 2 because we always want to circle our prime numbers. 3 is also prime. And 2 again is prime, and 3 is prime. So I can't break down any more numbers. It's as far broken down as I can get it. Alright, so now I'm going to write my prime factorization. Now your book says to write the prime factorization. Okay, it says nothing else. My instructions to you are I want you to write it in two different forms. Okay, two different forms you need to know. First one is called expanded form. And what expanded form means is write all the factors out. All the factors you have circled. Okay, I've got 4 different factors circled, so that means I should write 4 different factors right here. And I want to write them from smallest to largest. So first I've got 2 times, then there's another 2 times, and then a 3, and then another 3. Okay, that's expanded form. And if I did that correctly, all these numbers should multiply together to get the number I started with, 36. Well, 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. So it works. Okay, and the other form that you'll need to write is exponent form. Again, your book doesn't tell you to write both of these, but I want you to, so know the difference between expanded and exponent form. Here's exponent form. We're looking not for all the factors necessarily, but the different factors. So what different numbers am I multiplying together? Well, I'm multiplying some 2's together, and I'm multiplying some 3's together. Alright? But then, 2 times 3 does not equal 36. So what I have to do is put exponents that tell me how many 2's I have and how many 3's I have. Well, I've got 2 2's and 2 3's. So I put those as exponents there. Now if I multiplied those out, okay, 2 squared is 4, and 3 squared is 9, and 4 times 9 is 36, which is the number I started with. So again, exponent form, this number tells me the factor I multiply together. This one tells me how many times. So this means I have 2 2's that I'm multiplying together. This means I have 2 3's that I'm multiplying together to get 36. Alright, now let's do the other example, 45, with the other method I want to show you, downward division. Alright, and downward division is actually my personal favorite, okay, or division by primes. And again, the number we're going to use this time was 45. Okay? Now, I do like that Saxon calls it division by primes because that tells you what you have to divide by. Okay? You have to divide by prime numbers. So I have to figure out what prime numbers go into 45. So use your divisibility test. The first number I would always check is 2 because that's the lowest prime number there is. Well, we know 2 doesn't go into 45 because 45 is odd. Okay, it ends in a 5. So then we got to try the next prime number, which is 3. Okay, and 3 does go into 45. If you don't just know that, you can do the divisibility test. The divisibility test for 3, to tell if 3 will go into number, says I add up these digits. 4 plus 5 is 9, and I can divide 9 by 3. So that means 45 is divisible by 3. And 3 goes into 45 15 times, so I write that down here. And if you did not know that, you can do 45 divided by 3, and it goes in once, and then you subtract, and then 3 goes into 15 5 times. Okay, so that's actually showing the division if you need to. Now, 15 is still not prime. Okay? I cannot stop until I have a prime number left over. So, now I ask myself, again, start with the number you just left off with. Okay, we know 2 won't go into 15 because it's odd, but 3 will go into 15. Again, notice again, I'm using prime numbers out here, not composite ones. These have to be prime. Okay? Well, 3 goes into 15 5 times. Well, now I got to look at 5. Can I break 5 down anymore, or is it prime? Okay, if 5 is prime, I'm done. If I can break it down, I keep going with more division. 5 is a prime number, so I am done. I cannot break this 45 down any farther than I just did. Okay, so what I'm going to do now is I'm going to use these numbers on the outside. I'm going to make a nice little baby booty here. Okay, like you stick on a baby's foot. Maybe it's a nice Hawkeye booty. It means football season is going to be coming up here. So that means those are the 3 numbers I'm going to be multiplying together. Okay? And again, I'm going to use expanded and exponent form like I did last time. The book doesn't tell you to use both, but I want you to. Okay? So expanded form of 45. Again, go write out all the factors from smallest to largest. I've got 3 times 3 times 5. Alright? Now exponent form. Again, for exponent form, I want to know what different numbers am I multiplying together. Well, I'm multiplying some 3's by some 5's. And then I look, how many 3's do I have? I've got 2 of them. How many 5's do I have? I only have 1. Okay? I don't need to put an exponent when there's 1 because this number right here just tells me I have 1 5 there. And this tells me I have 2 3's. Alright? So that's my answer for that one. And I guess I forgot this before. We should always put our answers in boxes or circles for the 2 problems. Okay? The answers that are in the boxes are the kind of answers you would be expected to show on your assignment. The work that's up here, either factor tree or downward division, that's the work you'd be expected to show to get your answer. Okay? Happy homeworking!